Good day friends, welcome to my channel lecture series on power electronics. I am Dr. M. Santosh Rani. In this lecture we will be seeing about half wave rectifiers. Rectifiers convert AC to DC, alternating current to direct current, more precisely a bidirectional current to a unidirectional current. There are two types of rectifiers. They are classified based on the device used. If diodes are used for rectification purpose, then it is called as uncontrolled rectifier. If thyristors are used for the purpose of rectification, then it is called as controlled rectifiers. Let us see only the uncontrolled rectification aspect in this lecture. Before that, we will go into the applications of the rectifiers. Rectifiers find applications in the following: DC motor speed control. If the speed of a DC motor is to be changed, the DC value available for the motor has to be changed. For this, rectifier is used, and it is used for the input supply for the inverters. Inverters which convert DC to AC require a DC input. For that, rectifiers are used. In electrochemical processes, rectifiers are used. In DC traction, traction is railways, in that also rectifiers are used. HVDC transmission, that is high voltage DC direct current transmission, rectifiers are used. Let us see the half wave rectifier, the uncontrolled rectifier, which uses diodes for the rectification purpose in detail here. The input for a rectifier is a alternating current and the output is direct current. This is a half wave rectifier where only one diode is used. The AC input is normally represented by a sine waveform which has a positive half cycle and a negative half cycle. And this is a transformer which is used for either increasing or decreasing the AC voltage. In this case, it is a step down transformer. The higher value of AC input is reduced to the required value on the secondary side. Let us see what happens during the positive half cycle. During positive half cycle, in the primary of the transformer, the upper part is positive and this part is negative. The same thing is happening here also in the secondary. This is plus and this is minus. The diode will also get plus here, which is the anode, and will get negative on the other side, which is the cathode. A diode is said to be forward biased when it has anode positive and cathode negative. So when there is positive and negative in the shown way, it will be able to allow the current to flow through it. Now when during the positive half cycle, the current flows through the load because the diode is forward biased. There is a current flow in this loop. So the current flows from the secondary through the diode through the load and back to the negative. So here if we see the output, it will be just similar to that of the input. The positive half cycle appears as it is in the output. During the negative half cycle, the transformer will be having a negative polarity on top and the positive polarity at the bottom, which is also on the secondary side. So what happens now is the diode is getting negative at the anode and positive at the cathode. So it is reverse biased. It will not allow the current to flow through it. So no current will flow through the load. That is not going to be any current flow through the load. So there will not be any output. So here for a full cycle of AC input, we are getting only half wave, positive half cycle only are getting the output. But the rest it is not coming. So the same thing happens in the next cycles also. So we see that from the bidirectional input, you have got only unidirectional output. So from the AC input, alternating current, we are getting a direct current, though it is not a DC line. By using proper filters like capacitors just across the load, you will be able to make the AC into almost a straight line. This is called as an uncontrolled rectifier because we have used a diode here. If in the same place a thyristor is used, it is called as a controlled rectifier. The output will be slightly different from the from this case. So that we will see in the next lecture. This is a half wave rectifier uncontrolled. So the controlled rectifier we will see in the next lecture. Thank you.
In this lecture, we will see how to simulate a half-wave uncontrolled rectifier using PSIM. When a PSIM window is opened, it looks like this, and we go in for a new project. A window opens like this. As we know that for a half-wave uncontrolled rectifier, the components needed are the AC voltage source, a diode resistor, and measuring equipments. So let us take a voltage source, a sinusoidal voltage source, as we can see in the toolbar is available. A sinusoidal voltage source is taken. We click on the sinusoidal voltage source, take it and place it in the window. The excess one which is appearing here can be removed just by pressing escape. Now we need a diode which is available in the toolbar as well. So take it and place it here. Then we need a resistor. A resistor is a load. So here we have a resistor. This also we take it and place it here. Because we want the resistor in a vertical position, we'll right click on it. So the resistor becomes in the vertical direction. The excess one can be deleted. Now we need to have a earth that is also available in the toolbar, which is taken and placed over here. For measuring the voltage on the input side as well as the output side, we need a voltage probe. So we take a voltage probe which is also available in the toolbar. We'll put it here. This in the horizontal position. We want it in a vertical position. So we right click on it and place it here. Then we remove the excess one. We just delete it. We can have one more voltage source, voltage measurement on the output side. We copy it and place it here. So you can copy it and place it here, or take one more voltage probe from here and then place it here, right click on it, then place it here, press escape and remove the excess one. So these are the components required for the simulation of a half wave uncontrolled rectifier. Now let us connect all these things using the wire which is available here. So this wire is taken and it is connected to the diode. Again this diode is connected to the resistor. The resistor is connected back to the source, and the earth is connected to the source. This voltage measuring probe is also connected on the input side like this. Then we have another voltage measurement probe that is connected on the output side like this. Now we have to do the simulation. For running the simulation, we need to have a simulation control which is available in the simulate here. We take a simulation control and place it here. This one has a total time of 0.01 seconds, but let us make it as 0.05 seconds so that the simulation may show a more number of cycles. Now let us assign values for each of the components over here. This voltage source, we can right click and we press on the attributes. We can name it as the voltage source. We can simply name it as V, and if the square box is checked, it will be displayed there. Let us have the voltage as 220 volts and the frequency as 50 hertz. And if these two values are to be displayed also, we'll check the square boxes here. So now we see that the voltage value and the frequency is displayed here. Then let us go in for the diode. Diode's attributes, if we see, it's an ideal diode. It is marked as D. We can display it here by checking the square box. Then we'll assign a value for this resistor. Let us take the value as 100 ohms, and let us mark it as R, and it can also be displayed over here by checking the square box. Now we have the entire circuitry ready. It has to be now simulated. So we'll go into simulation and run simulation. When the simulation is run, we will be getting the output voltage. And here, one more thing we have to do in the circuit is we can give the value of this. Like for the voltage probe, we can change the term. That is, we can write it as V input here and we can display it here. So this voltage measurement, we can name it as V output. We are going to see the output from the probe. So now while simulating, we'll go in for this simulation, run simulation. Here we will see that V in and V out are available. If we want to see V in, we will select V in and we'll add it to the screen. Here we have the curves. Here we can assign a color for the curve and the thickness of the line can also be checked here. I'm just giving 3 over here. If I put OK, we'll be able to see the input voltage waveform, which is a sinusoidal waveform. We have given a voltage of 220 volts. So we see here 220 volts here. Now, if we want to see the output, we can go into the screen. We can add a screen. Here, we want to see V output. So, V output we will choose. We will add it to the screen. In the curves, we'll assign a different color for this. Let us take it as blue. And then the thickness of the wire also we can give it as 3. So, here, if we put OK, we can see the output also in the screen here. Now with this we see that we have the input voltage shown as a sinusoidal waveform. The output voltage is available. The output voltage is available only during the positive half cycles, and during the negative half cycle, because the diode is not conducting, there is no output value available here. So this is how we simulate a half wave uncontrolled rectifier using PSIM. In this lecture, let us learn about a half wave controlled rectifier. We have already seen this half wave uncontrolled rectifier. The components required for a half wave uncontrolled rectifier are a voltage source, a diode, a load, which is a resistor, and the measuring probes. Now, the requirement for a controlled rectifier is all the components other than the diode are same. So let us replace this diode in with the SCR. When you want to add a thyristor or a SCR in the circuit, it is available in the library or we can search for it. And when you type thyristor, it is available. That can be taken and placed here where earlier the diode was there. Now let us make use of the wire to connect the thyristor in the circuit. The thyristor has got three terminals, one anode, cathode, similar to that of a diode, and there is another terminal which is called as the gate. And this gate has to be given a pulse. When the pulse is given, the SCR starts conducting. To give the gate pulse, there is a gating block available in the library that has to be chosen and that is placed here in the circuit. Now we connect the gating block to the gate of the thyristor. The circuit is complete now. All the other things being the same, just like that of an uncontrolled rectifier. Here, the only difference is in the gating block, we can give the attributes in such a way that we get a waveform similar to that of a uncontrolled rectifier or a waveform which we want uh, to be different. That is, let us see how we give the attributes to this. Now we can see that in the gating block, the frequency is marked as 5000, but we have chosen a frequency of 50, and here the number of points is to be chosen as 2. The switching points are given as 0 degrees and 180 degrees. So here, let us have it as 0 and 180 degrees and run the simulation. Here we have the V input added. The curves we take it as red color and the thickness as 3. We can see the input waveform which is just similar to that of an uncontrolled rectifier. Now adding a screen and adding the V output with the color as blue and taking the thickness of the wire as 3, we see another output which is available here. This output is just similar to that of a diode. Here we see that the conduction starts at 0 degrees. During the positive half cycle, it ends at 180 degrees, and after that it is again starting at 0 ending at 180. This is what is the attribute we had given. So now what we can do is, in order that we get a different waveform, we will be giving the attributes different. Say we can give the attributes that the conduction has to start at say 45 degrees, and then we simulate it again. We can see that the input, just similar to the previous one, will look like a sinusoidal waveform. It's a sinusoidal waveform. And when we see the output, we take the color again as blue and the thickness of the wire as 3. We see that the conduction starts at 45 degrees and ends at 180 degrees. So in a controlled rectifier, we can get an output not similar to that of a controlled rectifier, uncontrolled rectifier also, but as we switch the starting point, we get an output which is showing a waveform like this. And here the output voltage will be lesser than that time when the firing angle is 0. Let us simulate for another value also and see. We give the attributes as 90 degrees and 180 degrees. So if you give 90 and 180, the conduction would start at 90 degrees. As already seen, the input will be a pure sine waveform. Adding a screen for the output, we can see that the output is starting at, thickness also will put it as 3, and we will see that the output starts at 90 degrees. So the difference between a controlled rectifier and uncontrolled rectifier is by changing the firing angle, or in simple terms the point at which the SCR starts conducting, we can get a variable DC voltage from a controlled rectifier, whereas we get a constant DC voltage output from a uncontrolled rectifier.